Lake effect snow is produced during cooler atmospheric conditions when a cold air mass moves across long expanses of warmer lake water, warming the lower layer of air which picks up water vapor from the lake, rises up through the colder air above, freezes and is deposited on the leeward shores. The same effect also occurs over bodies of salt water, when it is termed ocean effect or bay effect snow. The effect is enhanced when the moving air mass is uplifted by the orographic influence of higher elevations on the downwind shores. This uplifting can produce narrow but very intense bands of precipitation, which deposit at a rate of many inches of snow each hour, often resulting in a large amount of total snowfall. The areas affected by lake effect snow are called snow belts. These include areas east of the Great Lakes, the west coasts of northern Japan, the Kamchatka Peninsula in Russia, and areas near the Great Salt Lake, Black Sea, Caspian Sea, Baltic Sea, and parts of the northern Atlantic Ocean. A lake effect blizzard is the blizzard-like conditions resulting from lake effect snow. Under certain conditions, strong winds can accompany lake effect snows, creating blizzard-like conditions. However, the duration of the event is often slightly less than that required for a blizzard warning in both the US and Canada. If the air temperature is low enough to keep the precipitation frozen, it falls as lake effect snow. For lake effect rain or snow to form, the air moving across the lake must be significantly cooler than the surface air. Specifically, the air temperature at an altitude where the air pressure is 850 millibars should be 13 degrees Celsius lower than the temperature of the air at the surface. Lake effect occurring when the air at 850 millibars is much colder than the water surface can produce thunders. Now, snow showers accompanied by lightning and thunder formation. There are several key elements that are required to form lake effect precipitation and which determine its characteristics. Instability, fetch, winds shear, upstream moisture, upwind lakes, synoptic scale forcing, orography, topography, and snow or ice cover. Instability, a temperature difference of 13 degrees Celsius between the lake temperature and the height in the atmosphere, provides for absolute instability and allows vigorous heat and moisture transportation vertically. Atmospheric lapse rate and convective depth are directly affected by both the mesoscale lake environment and the synoptic environment. A deeper, convective depth with increasingly steep lapse rates and a suitable moisture level will allow for thicker, taller lake effect precipitation clouds and naturally a much greater precipitation rate. Fetch, the distance that an air mass travels over a body of water, is called fetch. Because most lakes are irregular in shape, different angular degrees of travel will yield different distances. Typically a fetch of at least 100 kilometers is required to produce lake effect precipitation. Generally, the larger the fetch, the more precipitation that will be produced. Larger fetches provide the boundary layer with more time to become saturated with water vapor and for heat energy to move from the water to the air. As the air mass reaches the other side of the lake, the engine of rising and cooling water vapor pans itself out in the form of condensation and falls as snow, usually within 40 kilometers of the lake but sometimes up to about 100 miles. Wind shear. Directional shear is one of the most important factors governing the development of squalls. Environments with weak directional shear typically produce more intense squalls than those with higher shear levels. If directional shear between the surface and the height in the atmosphere at which the barometric pressure measures 700 mb is greater than 60 degrees, nothing more than flurries can be expected. If the directional shear between the body of water and the vertical height at which the pressure measures 700 mb is between 30 and 60 degrees, weak lake effect bands are possible. In environments where the shear is less than 30 degrees, strong, well-organized bands can be expected. Speed shear is less critical, but should be relatively uniform. The wind speed difference between the surface and vertical height at which the pressure reads 700 mb should be no greater than 40 knots so as to prevent the upper portions of the band from shearing off. However, assuming the surface to 700 mb winds are uniform, a faster overall velocity will work to transport moisture quicker from the water, and a band will travel much farther inland. Upstream moisture. A lower upstream relative humidity will make it more difficult and time-consuming for lake effect condensation, clouds and precipitation to form. The opposite is true if the upstream moisture has a high relative humidity, allowing lake effect condensation, cloud and precipitation to form more readily and in a greater quantity. Upwind lakes. Any large body of water upwind will impact lake effect precipitation to the lee of a downwind lake by adding moisture of pre-existing lake effect bands, which can re-intensify of the downwind lake. Upwind lakes do not always lead to an increase of precipitation downwind. Synoptic forcing, vorticity, advection aloft and large upscale ascent help increase mixing and the convective depth, while cold air advection lowers the temperature and increases instability. Orography and topography. Typically lake effect precipitation will increase with elevation to the lee of the lake as topographic forcing squeezes out precipitation and dries out the squall much faster. Snow and ice cover. As a lake gradually freezes over, its ability to produce lake effect precipitation decreases for two reasons. Firstly, the open ice-free liquid surface area of the lake shrinks. This reduces fetch distances. Secondly, the water temperature nears freezing, reducing overall latent heat energy available to produce squalls. To end the production of lake effect precipitation, a complete freeze is often not necessary. Even when precipitation is not produced, cold air passing over warmer water may produce cloud cover. Fast-moving mid-latitude cyclones, known as Alberta clippers, often cross the Great Lakes. After the passage of a cold front, winds tend to switch to the northwest, and a frequent pattern is for a long-lasting low-pressure area to form over the Canadian Maritimes, which may pull cold northwestern air across the Great Lakes for a week or more, commonly identified with the negative phase of the North Atlantic Oscillation. Since the prevailing winter winds tend to be colder than the water for much of the winter, the southeastern shores of the lakes are almost constantly overcast, leading to the use of the term the Great Grey Funk as a synonym for winter. These areas allegedly contain populations that suffer from high rates of seasonal affective disorder, a type of psychological depression thought to be caused by lack of light. Great Lakes region, U.S. Northeast cold winds in the winter typically prevail from the northwest in the Great Lakes region, producing the most dramatic lake effect snowfalls on the southern and eastern shores of the Great Lakes. This lake effect produces a significant difference between the snowfall on the southern, eastern shores and the northern and western shores of the Great Lakes. The most affected areas include central New York, western New York, northwestern Pennsylvania, northeastern Ohio, southwestern Ontario and central Ontario, northeastern Illinois, northwestern and north-central Indiana, and western Michigan. Tug Hill in New York's North Country region has the second most snow amounts of any non-mountainous location within the continental U.S., only trailing the Upper Peninsula of Michigan, which can average over 200 inches of snow per year. Lake effect snows on the Tug Hill can frequently set daily records for snowfall in the United States. Tug Hill receives, on average, over 20 feet of snow each winter. In February 2007, a prolonged lake effect snow event left 141 inches of snow on the Tug Hill Plateau. Syracuse, New York, is directly south of the Tug Hill Plateau and receives significant lake effect snow from Lake Ontario, averaging 115.6 inches of snow per year, which is enough snowfall to often be considered one of the snowiest large cities in America. A small amount of lake effect snow from the Finger Lakes falls in upstate New York as well. The Appalachian Mountains and Atlantic Ocean largely shield New York City and Philadelphia from picking up any lake effect snow. Snow that tends to come from mesocyclonic storm systems mixing with cold temperatures. Lake Erie produces a similar effect for a zone stretching from the eastern suburbs of Cleveland through Erie to Buffalo. Remnants of lake effect snows from Lake Erie have been observed to reach as far as Garrett County, Maryland. Because it's not as deep as the other lakes, Erie warms rapidly in the spring and summer and is frequently the only Great Lake to freeze over in winter. Once frozen, the resulting ice cover alleviates lake effect snow downwind of the lake. Based on stable isotope evidence from Lake sediment coupled with historical records of increasing lake effect snow, it has been predicted that global warming will result in a further increase in lake effect snow. A very large snow belt in the United States exists on the Upper Peninsula of Michigan, near the cities of Houghton, Marquette, and Moonizing. These areas average 250 to 300 inches of snow each season. For comparison, on the western shore, Duluth, Minnesota receives 78 inches per season. Lake Superior and Lake Huron rarely freeze because of the size and depth. Hence, lake effect snow can fall continually in the Upper Peninsula and Canadian snow belts during the winter months. Main areas of the Upper Peninsula snow belt include the Keweenaw Peninsula and Baraga, Marquette and Alger counties, where Lake Superior contributes to lake effect snow, making them a prominent part of the Midwestern snow belt. Records of 390 inches of snow or more have been set in many communities in this area. The Keweenaw Peninsula averages more snowfall than almost anywhere in the United States, more than anywhere east of the Mississippi River and the most of all non-mountainous regions of the continental United States. Because of the howling storms across Lake Superior, which cause dramatic amounts of precipitation, it has been said that the lake effect snow makes the Keweenaw Peninsula the snowiest place east of the Rockies. Only one official weather station exists in this region. Located in Hancock, Michigan, this station averages well over 210 inches per year. Farther north in the peninsula, lake effect snow can occur with any wind direction. A road commission in Keweenaw County, Michigan collects unofficial data in a community called Delaware, and it strictly follows the guidelines set forth by the National Weather Service. This station averages over 240 inches per season. Even farther north, a ski resort called Mount Bohemia receives an unofficial annual average of 273 inches. Hermann, Michigan, averages 236 inches of snow every year. Lake effect snow can cause blinding whiteouts in just minutes, and some storms can last days. Western Michigan, western northern lower Michigan, and northern Indiana can get heavy lake effect snows as winds pass over Lake Michigan and deposit snows over Muskegon, Traverse City, Grand Rapids, Kalamazoo, New Carlisle, South Bend, and Elkhart, but these snows abate significantly before Lansing of Fort Wayne and Indiana. When winds become northerly, or aligned between 330 and 390 degrees, a single band of lake-effect snow may form, which extends down the length of Lake Michigan. This long fetch often produces a very intense, yet localized, area of heavy snowfall, affecting cities such as LaPorte and Gary, Indiana. Lake-effect snow is uncommon in Detroit, Toledo, Milwaukee, and Chicago, because the region's dominant winds are from the northwest, making them upwind from the respective Great Lakes. However, they too can see lake-effect snow during easterly and northeasterly winds. More frequently, the north side of a low-pressure system picks up more moisture over the lake as it travels west, creating a phenomenon called lake-enhanced precipitation. Ontario, Canada. Because southwestern Ontario is surrounded by water on three sides, many parts of southwestern and central Ontario get a large part of the winter snow from lake-effect snow. This region is notorious for the whiteouts, which can suddenly reduce highway visibility on the world's busiest highway from clear to zero. The region most commonly affected spans from Port Stanley in the west, Brantford and the Bruce Peninsula in the north, Niagara on the lake to the east, and Fort Erie to the south. The heaviest accumulations usually happen in the Bruce Peninsula, which is between Lake Huron and Georgian Bay, so long as the Great Lakes are not frozen over. The only time the Bruce Peninsula does not get lake-effect snow is when the wind is directly from the south. Toronto and Hamilton are usually spared lake-effect squalls because they are not on the leeward side of Lake Ontario during the dominant northwest winds. However, some central and northern portions of the Greater Toronto Area can be affected a few times each year by lake-effect snow from Georgian Bay. Downtown Toronto and Hamilton get most of the lake-effect snow when the wind comes from the southeast or east over Lake Ontario. Such easterly winds are usually associated with a winter cyclone passing just to the south of the Great Lakes. When the wind is from the north, the snow belt runs north-south from Hudben to Sarnia and London. Areas such as Lucan and Arkona have experienced some of the heaviest snow squalls from Lake Huron in this region. When the wind is slightly more westerly, the snow belt runs from Tobermory, Owen Sound, and Grand Bend to as far south and east as Arthur, Orangeville and Caledon. This snow belt often reaches Kitchener and can affect the Halton and Peel regions of the Greater Toronto Area. These northwesterly winds usually also bring snow southeast of Georgian Bay, which can reach beyond Lake Scugog. A westerly wind sends lake-effect streamers east from Owen Sound to Gravenhurst, Barrie, and Orillia, and may even reach as far south and east as York region in the Greater Toronto Area. When the wind is from the southwest, lake-effect streamers from Lake Huron and Georgian Bay run from Noëville to Sudbury, Gravenhurst, and Algonquin Provincial Park. Winds from this same direction coming over Lake Ontario will cause squalls to come ashore from Cobourg through the Belleville area to Kingston and the Thousand Islands, with Prince Edward County being the area most vulnerable to extreme snowfall amounts. Some snow bands can occasionally reach Quebec and Maine, while snow originating from Lake Erie, Lake Ontario and even Lake Michigan can impact southern Ontario. Easterly winds primarily affect the Niagara Peninsula. Local lake-effect snow squalls can occasionally occur downwind of Lake Simcoe when the lake is unfrozen, usually in early winter or late fall. Lake Superior has its own independent snow belts, affecting Wawa, Sault Ste. Marie, Marathon, the Keweenaw Peninsula in Upper Michigan, and Pukasqua National Park. Thunder Bay is usually not affected by lake-effect snow, unless it is associated with a winter storm. Elsewhere in the United States, similar snowfall can occur near large inland bays, where it is known as bay effect snow. Bay effect snows fall downwind of Delaware Bay, Chesapeake Bay, and Massachusetts Bay when the basic criteria are met, and on rarer occasions along Long Island. The southern and southeastern sides of the Great Salt Lake receive significant lake effect snow. Since the Great Salt Lake never freezes, the lake effect can influence the weather along the Wasatch Front year-round. The lake effect largely contributes to the 55 to 80 inches annual snowfall amounts recorded south and east of the lake, and in average snowfall reaching 500 inches in the Wasatch Range. The snow, which is often very light and dry because of the semi-arid climate, is referred to as the greatest snow on Earth. In the mountains, lake effect snow contributes to approximately 6 to 8 snowfalls per year in Salt Lake City, with approximately 10% of the city's precipitation being contributed by the phenomenon. The Finger Lakes of New York are long enough for lake effect precipitation. The Texas Twin Cities of Sherman and Denison are known to have experienced lake effect snow from Lake Texoma in rare instances. The Truckee Meadows and other parts of northern Nevada, which are normally in the rain shadow of the Sierra Nevada, can, when conditions are right, have severe snowfall as a result of lake effect from Lake Tahoe. Recent severe examples of this phenomenon have occurred as recently as 2004, dumping several feet of snow in the normally dry region. The West Coast occasionally experiences ocean effect showers, usually in the form of rain at lower elevations south of about the mouth of the Columbia River. These occur whenever an Arctic air mass from western Canada is drawn westward out over the Pacific Ocean, typically by way of the Fraser Valley, returning shoreward around a center of low pressure. Cold air flowing southwest from the Fraser Valley can also pick up moisture over the Strait of Georgia and Strait of Juan de Fuca, then rise over the northeastern slopes of the Olympic Mountains, producing heavy, localized snow between Port Angeles and Sequim, as well as areas in Kitsap County and the Puget Sound region. Rarely, the phenomenon of Gulf effect snow has been observed along the northern coast of the Gulf of Mexico, notably during Florida's Great Blizzard of 1899. Another extreme occurrence of ocean effect snow occurred on January 24, 2003, when wind off the Atlantic combined with air temperatures in the 20 degrees Fahrenheit brought snow flurries to the Atlantic coast of Florida as far south as Cape Canaveral. Elsewhere in Canada, Lake Winnipeg and Lake Winnipegosis in Manitoba historically have seen lake effect snows early as late October, and it is common throughout early to mid-November. Towards the end of November, the lakes sufficiently cool and begin to freeze, ending the lake effect snow. A brief period of lake effect snow is also common near Great Bear Lake and Great Slave Lake in the Northwest Territories during early winter. However, the lake effect season for both lakes is very short. The lakes are frozen roughly 18 months of the year and as a result have very little time to warm during the summer months. Other small lakes such as Lake Athabasca in northern Saskatchewan and Lake Nipigon in northwestern Ontario produce early-season lake effect snows. Smallwood Reservoir, a man-made lake located in Labrador, has on occasion generated lake effect snow. The Canadian Maritimes, specifically Nova Scotia and Prince Edward Island, are often affected by such snow squalls when an Arctic winter air mass moves over unfrozen waters. Impay sea effect snow is often generated when a cold north wind blows over the unfrozen Gulf of St. Lawrence, dumping heavy snow on the North Shore. In Nova Scotia, a cold northwest wind can produce sea-effect snow over the Cape Breton Highlands from the Gulf of St. Lawrence, and the Annapolis Valley from the Bay of Fundy. In the latter case, the sea-effect snow season can continue all winter as the Bay of Fundy remains open owing to its extreme tidal currents. Eurasia, lake-effect to sea-effect snow occurs in other countries, near large lakes or large sea areas. In Eurasia, it occurs in the regions of the Black Sea in Georgia and Turkey, the Adriatic Sea in Italy, the North Sea, the Baltic Sea as well as areas surrounding the Sea of Japan. Because the southern Black Sea is relatively warm, sufficiently cold air aloft can create significant snowfalls in a relatively short period of time. Due to its location on a peninsula between the Black Sea and the Sea of Marmara, Istanbul is very prone to lake-effect snow, and this weather phenomenon occurs almost every winter. This type of precipitation is generated by the warmer Black Sea temperature and colder air temperature over the Istanbul area. In February 2005, a lake-effect snowfall left 50 centimeters of snow, and in March 1987, a 3-week-long lake-effect snowfall accompanied with strong winds left 80 centimeters of snow in Istanbul. The snowfall in the eastern regions of the Black Sea is amplified by the orographic effect of the nearby Caucasus Mountains, often resulting in snowfall of several meters, especially at higher elevations. In northern Europe, cold, dry air masses from Russia can blow over the Baltic Sea and cause heavy snow squalls on areas of the southern and eastern coasts of Sweden, as well as on the Danish island of Bornholm and the east coast of Jutland. In the United Kingdom, easterly winds bringing cold continental air across the North Sea can lead to a similar phenomenon. Locally it is also known as lake-effect snow, despite the snow coming in from the sea rather than a lake. Similarly, during a northwesterly wind, snow showers can form coming in from the Liverpool Bay, coming down the Cheshire Gap, causing snowfall in the West Midlands. This formation resulted in the White Christmas of 2004 in the area. A similar phenomenon can affect the city of Inverness in the Scottish Highlands, where cold northeast winds cause heavy snow to form in the Moray Firth. This was the case with the White Hogmanay of 2009, which caused the street party to be cancelled. Northerly and northwesterly winds can cause the effect to occur over the Irish Sea and Bristol Channel, feeding snow into southwest England and eastern Ireland. Western Scotland and the north of Ireland can also see snow showers from a north and northwesterly wind over the Atlantic. Since the North Sea is relatively warm, sufficiently cold air aloft can create significant snowfalls in a relatively short period of time. The best-known example occurred in January 1987, when record-breaking cold air moved across the North Sea towards the UK. The end result was over a foot of snow for coastal areas, leading to communities being cut off for over a week. In recent years, lake-effect snow has been much lighter. Similarly, northern winds blowing across the relatively warm waters of the English Channel during cold spells can bring significant snowfall to the French region of Normandy, where snowdrifts exceeding 10 feet were measured in March 2013. The Sea of Japan creates snowfall in the mountainous western Japanese prefectures of Niigata and Nagano, parts of which are known collectively as snow country. In addition to the Sea of Japan, other parts of Japan, as well as Korea and Scandinavia, experience these same conditions. Moving of polar Siberian high-pressure centers along Caspian Sea regarding to relatively warmer water of the sea can make heavy snowfalls in the northern coast of Iran. Several blizzards have been reported in this region during the last decades. In February 2014, heavy snowfall reached 2 meters in the coastline in Gilan and Mazandaran provinces of Iran.